All right, so it looks like we have more factoring. So again, I'm going to go back to what I know, which is the simple or more simple plus 2x. There's nothing there, so there has to be an imaginary 1. X plus 1, x plus 1, oops. But it's not really x to the x, it's x to the fourth, so that's really x squared plus 1, x squared plus 1. But then there's really a y, and a y isn't on the front end, it's on the back end. So it's really x squared plus y squared, because 1 times y squared is y squared. And x squared plus y squared. And then I go, hey, why am I writing the same thing 2 times? My answer is x squared plus y squared. Squared. Okay? All right. Next one, asking me to factor. Well, I know I can take out a 2 because they all are even. And I notice they all have an x. But it's not just an x, it's x to the n. So that means that the 2 is gone. If I had 3 n's and I take away 1 n, I now have 2 n's. 14 divided by 2 is 7. I had 2 n's. I take away 1 n, I'm left with 1 left. And then there's a y. And then 24 divided by 2 is 12. I had 1 n, I take away 1 n, I got no n's, y squared. So the problem is that this is still a lot, because the n is frustrating to me and the y is frustrating to me. So I'm going to pretend it says x squared plus 7x plus 12. 2 numbers that multiply and add are x plus 3 and x plus 4. But it's really to the n, so x to the n. And then there's also a y, not on the front end, but on the back end. So more neatly, I will write my answer as 2x to the n, parentheses, x to the n plus 3y, x to the n plus 4. Oops, yeah, we're good. Okay. All right, let's look at the next one. It looks like there's asking for the points of intersection. So it looks like that's about 3, 1. And this looks like -3, 1. But when I look at the multiple choice, all they want to know are the x values. So just focus on the x, and that's b. Okay. All right, which expression is equivalent? So when I'm not even going to look there because that's a little bit intimidating to me. I'm going to look here and see that this is really 4 minus x squared. 4 square root, 2 minus x, 2 plus x. I also could have interpreted this way, square rooted from the beginning. 4 minus 2x, 4 plus 2x. So I feel like I did some of them already. I don't need to list all of them, but what's nice about it is now I can show that this one is equal to that one. Well, if this one works, then that one can't work. And if this one works, could this work? So it looks like what they did is if you look here, this and this are equal. Okay? And then there's the 2 plus x. So that works. And then this one is that one, so that works. Okay. And then I know it's not squared because one of them's positive and one of them's negative, so that's out. Now, if this was a multiple choice on your test, let's say, it would probably be worth 1, 2, 3, and then points for showing your work. Okay. So that looks about right. All right, determine the solution by solving. So there's different ways to go about this. A lot of you feel safe in the solve for y world, so I will solve for y. And then I'm going to take this -5/4, and it's going to go in for y. So I'll rewrite it as x squared plus -5/4x squared equals 41. All right. It looks a little crazy because of the fractions, but we can handle that. When you have a fraction, you square the top, square the bottom, and then you square the x. There's now different ways to go about solving this problem. I could add this plus this. So 1 plus 25/16 is 1 and 25/16, which is an improper fraction. But then it's still a fraction. So what I would prefer to do is get rid of the fraction. Again, do whatever you want. But what I do to 1, I got to do to all. So I'm going to multiply by 16, 16, and 16. And when I do that, I get 16x squared. This 16 goes away, plus 25x squared. And 41 times 16, I'm not going to pretend I'm that cool. 41 times 16, and I get 656. And now these are the same, so I add them together. So equals 656. When I solve for x, I divide by 41. I already know that's 16 because I multiplied, and now I'm dividing. But if you don't know what I'm saying, I'm going to go like this. 656 divided by 41. And I get 16. Oh my gosh, I had no idea. Now what do? I square root. And now I get two answers because it's squared. One of them's positive. One of them's negative. I got the x. Now I'm going to plug that in and get the y. So I'll take this 4 and I'll plug it in for this. It doesn't matter which one you plug it in for, honestly. Plug it in right there. And let's see. 5 times 4 is 20. Plus 4y equals 0. Move this over. Subtract 20. 4y equals negative 20. Divide by 4. Negative 5. Now I'm going to take this negative 4. Plug it in. Oops, let me just zoom out a little bit. So now I'm going to take this negative 4 and plug it in there. Play the same game. 5 times negative 4 is negative 20. Plus 4y equals 0. Add 20. 4y equals 20. Divide by 4. 5. Remember when I told you, I know I tell you a lot, but when you graph a circle, you notice the x and y values are related to each other. Okay? All right, last question. I want you to solve it algebraically and solve it graphically. I don't care which one you do first. I'm going to solve algebraically first. Since it says equals, I just set them equals to each other. Whenever I have a squared, I want to set that equal to 0, so this will move over here by doing the opposite. And I factor. My two values are 3 and negative 1. So now I have this x value and this x value. I take the 3 back. Here, let me zoom out a little bit. Take that 3, plug it in. 2 times 3, 6. Take that negative 1, plug it in. Do you need to show work? Of course you need to show work. So show me that. And there's your two answers. So when I graph it, I better get those two answers. So I could cheat a little bit. 1, 2, 3, 4, 5, 6. I know that should work. And 2, negative 1. Okay? Wait, that doesn't. Oops, I'm sorry. I'm looking over here. Is negative 1, negative 2. I knew something didn't feel right. Okay? So this is not really there. So now let me graph the first one. So if I'm going to graph this, I can always do it in pink. There's an imaginary plus 0. So I start at 0. And then I go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Oh my gosh, it's touching. I had no idea. And then down to left 1. Oh my gosh, it works. Okay. And then I draw my pink line. And now I'm going to graph this parabola. So I know there's a y-intercept of negative 3, so I can get that right away. So when I make my table, I'll put that in the center. And I know my other answers, so I'm going to try to be smart about this. Okay. Hopefully the y value is 6. I should probably check it out. 3 squared is 9, minus 3 is 6. Cool. 2 squared is 4, minus 3 is 1. 1 squared is 1, minus 3 is negative 2. Negative 1 squared is 1, minus 3 is negative 2. Negative 2 squared is 4, minus 3 is 1. So now I'm going to graph it. Left 2, up 1, down 1. Oh my gosh, no idea. 0, negative 3, 1, negative 2, 2, 1, 3, 6. Okay, so I've shown all of them. And I'm going to circle the points in common, which is here and here. And then I will rewrite them down here to show that whether I solve it by graphing or I solve it algebraically, I get the same answer. And this is your homework, so just make sure it's done.